In this video, we will be discussing the four macromolecules: carbohydrates, lipids, proteins, and nucleic acids. We'll be discussing their characteristics that make them the molecules of life. Before we discuss the four macromolecules, we need to talk about their special qualities and what makes them up. Inorganic compounds are any compound that do not contain carbon, and they are all considered to be non-living things. Examples of inorganic compounds would be water, salt, and minerals. Organic compounds is any type of compound that contains carbon, and these are all considered to be living things, except there is one exception, which is carbon dioxide. This is a non-living compound, but it is the only exception that is a compound that contains carbon and is considered to be non-living. Carbon is a unique element and a unique atom due to its structure. If you look at the picture that's rising above, you'll see that there are only 4 electrons in the valence shell right here. 1, 2, 3, and 4. We disregard any of the ones in the center because those don't bond. So we call this outer shell here the valence shell, and those are the only electrons in the shell that we pay attention to because they're the only ones that are going to bond. Now carbon has 1, 2, 3, 4 of them, and any atom on the periodic table needs to find 8 or have 8 electrons in its valence shell in order to be stable. So because carbon already has 4, it needs 4 more in order to be stable, which means it's able to make 4 bonds. This allows carbon to bond with elements such as hydrogen, oxygen, phosphorus, and nitrogen, all forming those biomolecules that we discussed before: carbohydrates, lipids, proteins, and nucleic acids. Polymerization is the process by which large compounds are constructed by joining together smaller compounds. So as seen here in the picture, we have monomers, which are smaller compounds, joining together to form a larger compound called a polymer. A monomer is a subunit that serves as the building block of a polymer. So if you see here, the prefix mono, which I'm going to underline right here, the prefix mono means one. So therefore, a monomer is one single subunit. A polymer is a large molecule that consists of many identical or similar monomers linked together. So poly means many. If you have multiple monomers coming together, as seen in the picture below, you have one single monomer, which is one single subunit, another monomer, joining together by covalent bonds. We now have formed one large polymer. Remember, the way to distinguish between monomers and polymers is that mono means one, poly means many, so monomers are single subunits that join together through covalent bonds. That's what these little lines here represent, are covalent bonds. And your product is one large polymer. So an example that we can use to describe the difference or the relationship between monomers and polymers is, let's just say that a monomer is one single brick. If we have one each single brick representing a monomer, which is one single subunit, when you have multiple of these small bricks, each individual bricks coming together, eventually they'll form one large brick wall, which would be represented as a polymer. The cement then holds together these bricks. Okay, all of this cement right here could be representative of the covalent bond that holds monomers together to form polymers. There are two different types of reactions when discussing the relationship between monomers and polymers. The first one we're going to discuss is a condensation dehydration reaction, and that's the first one up here on the top. So when you think of the word dehydration, you automatically assume dehydration. When you feel like you're thirsty, you don't have enough water. We can use that term to help us remember what goes on in this reaction. Here we have a very general picture of what's happening. Over here we have our reactants, and over here we have our products. Our reactants are going to be two separate monomers. So we have one monomer plus another completely separate monomer. For our product side, we're going to form these two monomers together. We're linking the monomers and we are forming a polymer. When we form that covalent bond that's shown here between the two monomers, which links them together and forms a polymer, there are two hydrogen atoms and one oxygen atom, aka H2O, that will not fit anymore and therefore is removed. When we have a loss of water, we consider that to be a dehydration reaction. Again, think of when you're dehydrated, you have a loss of water. When we join two monomers together to form this covalent bond, we have a loss of one water molecule. Now this overall reaction is what we call a synthesis reaction. And anything with the word synthesis means to build up. So when you're building something, we're taking two small pieces, which are our two monomers, and we're building them together to form one large polymer. Now let's take a look at the hydrolysis reactions. Okay, this is the exact opposite. So now we're taking polymers, or one large polymer, and breaking it down into two separate monomers. Here we have our covalent bond. When we add water back in, we break this covalent bond and we separate our two monomers. So an example of what happens when you eat, okay, when you're eating, the process of digestion is to break down food. And as you can see here, this is a lysis reaction. This is a breaking down process. We're taking a large polymer and we're breaking it down into smaller monomers. When you eat food, your body digests it and breaks it down. And typically what happens when you eat? Most likely you get thirsty and you want water. Well, what your body is doing is it's saying, hey, I need water in order to break the bonds of the polymer, aka food, and break it down into smaller monomers so it can be digested.